Let's talk about an example of solving equations with a linear equation. Here's an example from the textbook. Notice that there are three possible outcomes. The first outcome will be if I get a specific finite answer. If that's the case, then this is a conditional equation. The second case would happen if the answer would be all real numbers. That only occurs if the equation is an identity. The final outcome is that there is no solution. The solution set is the empty set or null set. That happens when the equation is what we call inconsistent. Now, let's go ahead and solve this particular equation. Notice we have parentheses, so I will need to use the distributive property. There's an understood 1 in front of the first parentheses. So 1 times x and 1 times negative 2 would give me x minus 2. Negative 2 times x and negative 2 times negative 1 gives me negative 2x plus 2. Watch your signs. Then I will bring down the equals. I will also bring down the x and the plus 1. They are not inside parentheses. Last but not least, there's an understood negative 1 in front of the final parentheses. I will multiply that times everything inside, getting a negative x and a positive 2. Now I will combine like terms on the same side of the equals. The equal sign is almost like a fence or a barrier between the left and right hand sides of this problem. So I have a 1x and a negative 2x. When I combine those, I end up with negative 1x. Negative 2 and plus 2 would cancel out, giving 0. That's equal to, on the other side, I have 1x minus x, which is 0. And 0 plus 1 plus 2 is going to give me 3. So I end up with negative x is equal to 3. I must now divide out that negative sign. Remember, that's an understood negative 1. So I'm basically dividing both sides of the equation by negative 1. The solution is x equals negative 3. Since I do have a specific one-answer solution, this equation is conditional. And that's it.